do a quick video on the proof of the true value of pi 3.11769145536, and it is found in the special right triangle that's inside of every circle. Every triangle is formed out of the circle. School teaches the 1-inch radius, 2-inch diameter circle, and they store the heights, the lengths in the phone under sine. Okay, sine is this distance right here to the middle of the circle, to the circumference point. So sine 60 is 0.8660254.038. That's the distance right here. Whenever your radius is 1, everything is going to be slightly, gradually lower than 1, all the way down to 0. Okay, and you can, since the circle is symmetrical, it mirrors itself. So the 89-degree sine and sine 1 will create a triangle. If you square both of them and add them together, you'll see that you get 1. And you can also do it with the whole circle. You can do it with any circle, either half of it, and use the radius as your hypotenuse, or you can use the whole circle and use the diameter as your hypotenuse, because just think about it, the 90-degree corner, it's away from it. So this opens up and creates this length right here. So if you use this as 2, and then pick 2 other symmetrical 73 and 17, 80 and 10. Any 2 numbers that add up to be 90. 89 would go with 1, 88 would go with 2. So all these lengths create a triangle with the hypotenuse and the diameter. So that being said, you see this special right triangle right here. 2 is the hypotenuse. 1 is the distance, the total height at the 30-degree point, but it's also equal to your radius. So 1 is the radius, and it's also the opposite. And then your 6300 chord is what the school would teach that is called, but it's the height of the circle at 60 degrees, and it's also the adjacent of this special right triangle. And this holds the key to the circumference and what they call the curvature. It's all based upon this triangle right here inside this circle, because you have your diameter, you have your radius, and then your adjacent is the 6300 chord. So if you take 1 divided by 360, you'll see that there is 0.2 repeating 7 units, okay, in each one. And we know there's 360 degrees in a circle. The reason that is because whenever there were 3.6 inches of circumference, this measurement right here was 1. Okay, this is the base 1 triangle adjacent. And this is the base 1 diameter hypotenuse, and this is the base 1 radius opposite circle. So these are the 3 base 1 circles out of this special right triangle. But if you take this measurement right here, you can either multiply it by 3.6, or you can divide it by 0.27 repeating, and you'll get the same answer as your circumference, just as if you would take your diameter and multiply it by the true value of pi. So if you we'll start with the 1-inch diameter circle. If you take 0.8660254.038, which is sine 60 on your calculator, and that's whenever it's a 1-inch radius, but the circle grows in unison. So the height at the 1 inch radius is the same height in the 1 inch diameter for the whole part of the circle. But if you take this measurement and times it by 3.6, you'll see that you get 3.1176914,536. Okay, and then take 1 and obviously times it by 3.1176914,536, you get the same answer. If you take 0.8660254,038 and divide it by 0.27 repeating, you'll get the same answer as pi. We move on to the 2 inch diameter, 1 inch radius. If you take 1.7320508,076 and divide it by 0.27 repeating, the answer you get will be 2 pi, which is 31176914536 times 2, which equals 6.23538,29072. And you could also take 1.7320508,076 and multiply it by 3.6 and get your circumference as well. And then for the base one adjacent, like I said, whenever it's 1 inch, if you take 1 inch and divide it by 0.27 repeating, you'll get 3.6 inches. Okay, if you take 1 and times it by 3